Welcome to Knowledge Search channel. In this video, we will be discussing about a source transformation. That is, we will be converting a voltage source to a current source. So there are two different types of source transformation. So one is the voltage to current source, the other one is the current to voltage source. So first, in this video, I will be discussing about what is meant by source transformation and what are the different types of source transformation. And in that particular case, we will be discussing about the voltage to current source transformation in detail. So this is what we are going to discuss in this video as a full video. Okay. So now we will move on to the topic. So but before going into the topic, I just want to brief you about what is a voltage source and what is a current source, so that those who have not watched the previous videos, they will be having a better understanding of what is a voltage source and what is a current source. And then we will go to the source transformation, what is the need for source transformation, and then we will be discussing about how to convert. Okay. So as you all know, what is a voltage source? A voltage source is nothing but a source which is having the voltage constant irrespective of change in magnitude of load. Whereas the current source is nothing but the current is always constant irrespective of change in current. So this is what it's all about. Okay. So this is how the energy sources has been discussed, and if you have any doubts, you can just go to the previous videos, you can watch and come back. Okay. So now again the source transformation circuits, again I am broadly classifying as voltage to current source, the other one is the current to voltage source. So here we will be discussing about some case studies. Okay. So this is a case study. Okay. This is a case study of how this voltage can be converted to a current source. Okay. So later we'll, in the second forthcoming video, we will be discussing about how the current is converted to voltage. So I will brief you what is a voltage source we have discussed in the previous video. So you can see that how to convert into current source is nothing but, so if you have a voltage source and if you have a series resistance Rs, so here you can see that I will be equal to V by Rs. Okay, I will be equal to V by Rs. This Rs should be marked in parallel. Suppose if I am having the voltage source with this place negative and positive. So here in this first diagram, you can see that it is positive and negative. Here in this case, it is negative and positive. Always this arrow mark should be pointing towards the positive direction. So here again, it is V by Rs. Rs will be in parallel. So this is how the voltage to current source is being done. Is it clear? So hope you are able to understand how this voltage has been converted to current. And similarly, how this current can be converted to voltage is nothing but, so always you know that the current source will be having a source resistance. So this source resistance, if you convert into a voltage, it has to be converted in series. So this is how it looks like. Okay, this is how it looks like. So whereas voltage source V will be equal to I into Rs. And similarly, similar to the previous case, where if the arrow mark is on upper direction, that should be the positive plate. And similarly, the arrow mark is in the opposite direction, should be always representing the positive plate in the arrow mark side. Okay. So this is how the things goes on. Okay. So hope you are all clear with what is a voltage source, what is a current source, and how to convert the voltage to current source. So why we are doing this actually? So why we are doing this voltage to current and current to voltage is nothing but, so in many cases your circuit will be having n number of voltage and n number of current sources, where you want to simplify that particular circuit in order to understand the behavior of the circuit, or you have to plot the characteristics of the circuit theoretically. So in that case, you want to simplify the circuit. So in many cases, you will be doing that voltage to current transformation, current to voltage transformation, everything has to be done. So in order to achieve it, we have to understand how it has to be done. Okay. So this gives you a basic idea. So in this video, we will be discussing only about the voltage source to current source, and the next class how to convert the current source to voltage source will be. So here this is the case study problem which I have taken. So you can see that in this problem, you can see that a 120 volt voltage source has been connected in series with the 10 ohm resistance. So here I have given the diagram. So it has been connected in series with the 10 ohm resistance. So then if you want to convert that particular voltage source to current source, you can see that it is having so you can see that what will be I will be equal to, as per the Ohm's law, is nothing but V by R. So 120 divided by 10 ohms will be giving you 12 amps will be given. So I will be equal to 12 amps and Rs will be in parallel with the current source. So why I have marked this arrow in downward direction is because this 120 volt source is having the positive in the lower lower terminal. So here I can see that I will be in down. So suppose if I am having the plus in the upper side, then this arrow mark will be on the upper side. So this is how we are going to convert a voltage source to current source. So here also I just want to share some students presentation during the class hours. The case study video has been done. So let's go back to that particular video and then.
Okay, in this video, Ms. Monica will be explaining the pros and cons of two-stroke engine, and Kamal will be explaining the pros and cons of four-stroke engine, and Gopal will be giving you the explanation of which is more suitable, whether the two-stroke engine technology or four-stroke engine technology is more suitable for HCV applications. So that's what the discussion is about in this video. So now I go on with Monica. Please tell me what are the pros and cons of two-stroke engine. So the power is very high, but the power to weight ratio is good. Okay, in this case, size on the company. So we need less size when compared to four-stroke engine. But the problem is having less weight, but more noise will be there. That's the main problem with this. Simple in design. Since it is simple in design, the manufacturing cost is very less, and also manufacturing cost can be maintenance cost can be. So I think the problem is okay, good. And now can I ask somebody can you tell me what is the advantage of four-stroke engine?
நாய்ஸ் வந்து கம்மியாக இருக்கும். டூ ஸ்டோவை கம்பேர் பண்ணுறப்ப ஃபோர் ஸ்டோக் வந்து காம்ப்ளெக்ஸ் டிசைனாக இருக்கும். மேனுஃபேக்சரிங் காஸ்ட் வந்து ஃபோர் ஸ்டோக் அதிகமாக இருக்கும். அப்புறம் மெயின்டெனன்ஸும் நிறையா இருக்கும். ஃபியூயல் எஃபிஷியன்ஸும் அதிகமாக இருக்கும். பொல்யூஷன்ஸ் வந்து கம்மியாக இருக்கும்.
So can I now ask Mr. Gopal, can you just compare both the technologies and let me know which will be more suitable for HCV?
We now talk about the HEV. HEV go to reduce the pollution. The pollution of computer करता है HEV को range वेणो நம்ம pollution ஒரு கம்மி பண்ணனும். அதுக்கு நம்ம HEV பண்ணோம். four stroke engine போனா பெட்டர். ஏனா four stroke engine வந்து maintenance cost எல்லாமே போடுறோம். pollution ரொம்ப கம்மி. அதுல HEV போறப்போ பேட்டரி சார்ஜ் பண்றப்போ இப்போ four stroke engine எடுத்தா பவர் இதெல்லாம் இருக்கும். pollution ரொம்ப அதிகம். நமக்கு ரொம்ப பவர் தேவையில்லை HEV போகிறப்ப EV மோட்டர் வந்து நம்ம பவர் ப்ரொடியூஸ் பண்ணிக்கலாம். ஸோ அதனால டூ ஸ்ட்ரோக் ஃபோர் ஸ்ட்ரோக் பெட்ரோல் HEV ரைட்.
So from this you can conclude that four-stroke technology is more suitable for HCV application compared to the two-stroke engine technology. So thank you all.